Hello. Today I will show a justification to why the power rule works. In this case, for my proof will be only for powers of integers greater than 0. So this is the power rule that we have here, that every time that we need to get the derivative of x to the power n, we will put the power multiplying the x and reduce the exponential by 1, right? How are we going to show that this is really happening? Why the derivative is really this? So for that we will use the formula, the derivative formula that we know that is the limit of the change when this change tends to be very, very small, infinitely small, right? So what do we have to do? We have that x here is this, right? So if we get the derivative of this, we will have the limit of this n that tends to 0, sorry, very, very small. And we will have that this will contain the x, right, plus this h to the n. This is an n, no h. Minus to this one, to the n, right? And this we have the h here also. Okay, so what we should know about this will expand in this way, right? We will have the the x to the n, right, plus n x n minus 1 multiplying by h, right, plus, and from here and all the way down to h to the n, all the terms that we have here will contain h. This is something that we have to contemplate, right? So how can we do the expansion of this? We don't know the expansion because this is n. It will be any number. Limit n tends to be 0. However, we know that the first term x to power n will go away with this one, right? We have plus n x n minus 1 h plus h to the power n minus x to the n, right? And this will go away. We can take the factor, right, the common factor, which is h here, and we will have the limit of h tends to 0, and we have h here as a common factor that going from n minus 1, right, is multiplying this, plus all these factors plus h to n minus 1. So this is n minus 1 because we took 1 from here and put it up front, and we have this dividing, right? And we can distribute the limits on all the terms that we have here, and we see that the limit n tends to be 0 of n, this is h, I'm sorry, h, and this 1/2. H is not anywhere here, so this term basically become the same. For the other ones, we will have the h there, so the h will become 0 and the limit will be 0, right? So basically this one is why we have this property of the power rule for the derivatives. Thanks.